Bubar. I'm President and CEO of Avalon Advanced Materials. And I'm a geologist, and today I thought I would talk to investors a little bit about the geology of lithium and what investors should think about from an investment standpoint about lithium geology. Lithium is a lot different than a lot of other more familiar exchange-traded commodities. It's basically a specialty material. And unlike a commodity like gold, where a lot of the investment risk is associated with just finding an adequate resource in the ground in terms of numbers of ounces, with lithium and other specialty materials like it, it's really all about defining how you can extract a marketable product from that and demonstrate that you will have market acceptance. And the geology of the resource is very relevant to that. There are many different types of lithium resources out there. So I thought I would share some insight into that from my 20 years of experience in doing exploration for hard rock lithium deposits in Canada. Next slide. Next slide is just the standard disclaimer on forward-looking statements. I don't think I'll be using any in this presentation today, but if I do, please don't rely on them. So Avalon, as I say, has been in the business of exploring for lithium and other specialty metals and minerals for most of the 20 years that I have been CEO of this company. And right now we have three active advanced projects, different levels of advancement. Our main lithium project is called Separation Rapids in northwestern Ontario near Kenora. The other two projects, although they're primarily of interest for other commodities, East Kemptville for tin, Nechalacho for rare earths, also do contain lithium as potential byproducts. And I'll explain a little bit about why that is and how that relates to geology as we go forward here. Next slide. So beginning with lithium in nature, just a few basic facts about lithium. It's very widely dispersed in the Earth's crust. It's a relatively abundant element, 31st most abundant. And that's good news for users of lithium going forward, in that it essentially means that I don't think the world will ever run out of having adequate lithium to meet the needs of industrial users. Its primary concentration in the crust on average is about 20 ppm. It does get concentrated initially in what are known as magmatic rocks. These are granites that form from a melt in the lower crust or upper mantle. And that's how lithium is primarily concentrated initially. But it is a metal that's an alkali element and unstable in the metal form, and typically is found in nature in the oxide form and silicate minerals in these granitic rocks, or as salts, as chlorides in the well-known brine deposits. In terms of its uses, you're familiar with many of the industrial uses. People always wonder about toxicity of elements like this, and in the case of lithium, it's actually has some beneficial aspects to it from a human health standpoint. Lithium carbonate is used in the treatment of depression, and it has been suggested and noted that low levels of lithium in water are also effective in treating depression and generally making people happier. And as illustrated in a slide, there's actually a product being marketed today you may be familiar with called Happy Water. And it's what makes it Happy Water is the fact that it does contain dissolved lithium in it. So you give it a try and see if it makes you happier. And in the meantime, what's happening in lithium markets is starting to make investors happier all the time. Next slide. So as I said, the primary concentration for lithium is in granites, in which are called magmatic rocks. And geologically, there are two primary series of these. NYF, niobium fluorine, is where lithium can be elevated and perhaps recoverable as a byproduct, such as in our Nechalacho resource. But LCTs, lithium cesium granite, tantalum granites, are the ones that have the highest concentrations of lithium, and from which many of the economically important resources are derived. Next slide. So LCT granites can spawn different types of primary lithium-enriched rocks. On the right are volcanic rocks, extrusive rocks called topaz rhyolites. Don't know of any of those that have produced economically important lithium deposits. In the middle are granites called apogranites, and that's where lithium and the other elements of economic interest that occur with lithium get concentrated in the fluids that accumulate at the top of the magma chamber when the granite is crystallizing, and then crystallize right there, sort of draped around the top of the intrusion. They tend to be similar mineralogy as pegmatites, but more widely dispersed in lower concentrations. There may have been a productive example of one of those in China, but they're not commonly being looked at now as potential economic resources. The ones that are being looked at are the pegmatites. That's where you get the highest grades, highest concentrations of lithium. That's the type of resource that we're looking at, and many other companies active in exploration in Canada are looking for these pegmatite type deposits as sources of lithium. And then at the top are a group sort of generally that can be considered secondary deposits or derived deposits that form as a result of the weathering and reconcentration of lithium from one of these primary resources associated with LCT granites. And of course the brines or salars and the clays are examples of those that are also being looked at as economic opportunities to produce lithium. Next slide. So focusing first on the primary deposits, hard rock pegmatites, and they typically contain lithium in concentrations ranging from 1 to 2.5%, a lot higher concentration than any of the other types that we'll talk about. And that's why they've always been the sort of primary go-to source of lithium for mining and economic recovery. Then some of the examples of lithium enrichment in granite where or granites where they can be recovered as a byproduct are actually tin Greisen systems. That's what we have at our project in Nova Scotia called East Kemptville, where lithium occurs in a mica called ginvaldite, actually in the rocks peripheral to the main tin resource, but potentially recoverable as a byproduct. And there's one company looking at a similar resource in the Czech Republic in the Saxony region. It's also a tin deposit that has the same mineral ginvaldite developed that could be an economic resource there as well. And then in these apogranites, the lithium tends to occur in micas and another mica called lepidolite. And they all have their own different challenges in terms of economic extraction, concentration, and ultimately extraction of the lithium. And illustrated in that photo there is a photo of our lithium pegmatite at Separation Rapids as it looked back in 1998 when it was first discovered and stripped off for mapping and sampling. And it's a rare example of the most highly evolved types of lithium pegmatites enriched in a mineral called pedalite that has virtually no impurities in it, and of major economic importance not only for lithium chemicals for batteries but also for other industrial uses. Go ahead. Next slide. So a little bit more science and geology on how pegmatites evolve. So pegmatites basically are spawned from a granite. In that granite magma chamber, the the fluid phase will accumulate at the top of the magma chamber and may get trapped there for an apple granite, but if it's able to escape into fractures around the rocks hosting the granite, then it will move out and crystallize slowly into these rocks called pegmatite. And the more evolved or fractionated that fluid is, the higher the concentrations will be in the incompatible elements such as lithium, cesium, and tantalum. And the ones that are enriched in pedalite, such as we have at Separation Rapids, tend to be the most highly evolved. They tend to be located the furthest away from the original granite source and represent a very challenging exploration target because they tend not to be geophysical responders. You need to rely on other information to generate exploration targets. The spodumene-rich pegmatites are sort of the next step down in terms of fractionation from the original source. Because of that, they'll have other things mixed in with the lithium minerals, and spodumene itself is different from pedalite in that it contains iron and magnesium elements that you want to remove from certain applications where lithium is used. So that's the other benefit of the most highly evolved pegmatites is lack of impurities such as iron and magnesium that are undesirable in some of the end uses for lithium. Next slide. And the most famous example of one of these LCT pegmatites in Canada anyway is the Tanko mine in Manitoba. It hasn't been a big producer of lithium. It was mostly mined for tantalum and more recently cesium. But it's one of the better examples, and you see three others. The Greenbushes mine in Australia is still a major producer of lithium in Western Australia is another example of this. The mineral there is spodumene, but it was actually originally pedalite that was metamorphosed to spodumene. There's one in Zimbabwe called Bikita. That's the only other significant economic resource of lithium mineral pedalite. I believe they're mainly producing cesium from that pegmatite right now. And then there's ours at Separation Rapids. Next slide. And this is our East Kemptville, just as an example of the tin Greisen type of lithium resource, of which the lithium mineral is this mineral zinwaldite. I don't know that there's any production from this yet, but obviously it's something that companies are starting to look at now. And as we look more at the East Kemptville opportunity, we'll be looking at the possibility of recovering lithium there as well as a byproduct, because basically it's concentrated in the waste rocks and gives us something economic to recover from the waste rocks peripheral to the main tin resource. Next slide. So moving on now to the secondary deposits, and the two that are of most economic interest today, of course, are the saline brine deposits, most notably in South America, northern Chile, Argentina, and Bolivia, where lithium occurs in very low concentrations, only at levels of sort of 100 to 200 ppm, but can be recovered fairly easily in evaporation ponds as a byproduct of salt production. So that has been for a long time the main source of lithium chemicals for the applications where chemicals are needed, because it's fairly easily recovered as a byproduct of salt production in this type of deposit. And then the other example that's being looked at now are clays, which are, I think, basically a dried up brine resource where the lithium is now out of solution and in clay minerals. The lithium tends to occur in these at a little bit higher concentrations, 1,000 to 2,000 ppm, but there are not any major productive examples of this yet. Several are being looked at as potential resources. One was Western Lithium's project in Nevada, where the mineral is hectorite. And as far as I know, they have yet to come up with a process that works there to recover the lithium into a saleable form economically. And that's one of the main things, as I'll repeat, that needs to be considered in all these lithium resources. Is they all have their challenges in terms of being able to concentrate the lithium first, and then extract the lithium into a form that will be saleable in the market. Next slide. And so there's quite a few different mineral products that lithium can occur in that can be produced and potentially used as concentrates to extract a lithium chemical product from for the battery market going forward. The two main ones in pegmatites are spodumene and pedalite. There's also a lithium mineral called lepidolite, sometimes referred to as polylithionite. There are other micas that can contain lithium, such as zinwaldite. There are the clay minerals, and then there are other more exotic minerals such as amblygonite, montbrazite, phosphates, and other such minerals that can also contain lithium. Each one of these has its own properties from a beneficiation and extraction standpoint, and different benefits and potentially risks associated with them in trying to recover a specific product from them. For the applications in glass ceramics, really only spodumene and pedalite are usable. The other ones are not, and it depends on the quality of the spodumene and pedalite to be used in glass ceramics. And then it's getting even more complicated now in terms of the lithium chemical products. For a long time it was just lithium carbonate, which was the chemical that's most easily produced from the brine resources. But as the battery technology evolves, there's starting to be demand for other lithium chemical products to use in battery compositions, cathode compositions. And many of them for the automotive industry are going increasingly to lithium hydroxide. That requires an extra step if you're making lithium carbonate first. And some are even talking about lithium metal foil now for some of the solid state batteries using lithium that are now being contemplated out there. So the range of products that you can sell lithium as is becoming more diverse. And so if you're seeking to produce lithium, you really have to think about what you want to produce, how you want to produce it, and what it needs to look like in order to have a market to sell it into. And in a very rapidly evolving market like this that's changing very quickly, one needs to kind of look forward a little bit and see where that market is going. And that's basically what we've done. Lithium hydroxide seems to be the way a lot of the automotive industry is going for the battery compositions they need for lithium-ion batteries. And lithium hydroxide can be made directly from the mineral concentrate, as has been already demonstrated by Nemaska, and as we're discovering we can do with our resource as well. And that's where the hard rock resources have an advantage in this lithium chemicals market that they did not have historically. And then the photo on the right just shows another example of lithium minerals are actually gem minerals that are quite valuable. These specimens are actually on display at the Royal Ontario Museum. Next slide. Just quickly reviewing the markets, just to make the point that there are many different markets for lithium out there that are very different in terms of what is the form of lithium that they need to make those products. Obviously, the battery application is the one that's attracting the most attention and interest right now, and has the most potential for growth in the medium and long term. But all these markets could be applicable to any given resource. And as I said earlier, for ceramics and glass, that has traditionally been the largest consumer of lithium. What's actually preferred there is the mineral form, depending if it meets purity requirements of the glass makers to make low thermal expansion glass. And all of these now have increasingly demanding product specification requirements that the producer must take into account before they assume they're going to be able to sell a product into those markets. That's really one of the most important things for investors to remember. Is it's not so much about the tons and grade in the ground, it's about how you're going to turn that into a product to serve the marketplace. Next slide. And so this slide kind of summarizes those key points in terms of investment risk. If you're looking at investing in aspiring new producers of lithium, these are some things that you should be thinking about. Because, as I think I mentioned earlier, unlike most commodities like gold, the investment risk is not so much with the integrity of the resource, it's whether you can turn it into a saleable product at the end of the day. And whether you have the technology and the ability to process that ore, first to make the concentrate, and then get a product out of that concentrate that is saleable in the market. That's where most of the risk is, and that's what investors need to be thinking about, and the geology is very much a relevant factor, and that can help in making that assessment early on in terms of what resources and what companies have the most or best prospects going forward. Not all lithium deposits are amenable to serving all markets, and each application has its own specifications that are often very demanding. So it's all about efficiency of extraction processes, and that depends on geology. And that's why in our company we've spent most of the last year really just working on how we can most efficiently extract the lithium from our petalite resource to make a product from the battery industry. We haven't really worried too much about the resource. We can do that later. The first thing is to know that we can make a product that will be accepted in the marketplace. And I think that's the #1 criterion that investors should be thinking about too as they look for opportunities to invest in lithium equities. That's basically what I had to say on Lithium Geology 101 and for investors, and the last few slides are just information on who we are, our management team and board. Main point here is we have the expertise to take a project such as Separation Rapid through the feasibility stage. All that expertise is resident in-house. And the next slide provides some information on our capital structure. And I think the main point here is because we've been sort of in the background, known mostly for our previous focus on rare earths, that many people don't know that we have an advanced lithium project. And I think that's yet to be discovered, and once we are able to disclose the results of our preliminary economic assessment, which is coming up in the next week or so, I think investors will be awakened to what is an interesting opportunity here that's yet to be discovered in the marketplace. So that's basically the story, and I'd be happy to take any questions either now or through email inquiries going forward.